want to talk about implementation of Boolean algebra, sorry, Boolean function. Yeah, implementation of Boolean function. Okay, with gates. So with gates. These are the digital gates that we introduced here, and we numbered 1 to 8. Okay. So what it tells us any function that you have in Boolean algebra, you could implement them with the gates. So let's see how. Let's actually have one example, which is the example practice exercise example on page 55 in the book. So it says draw a logic diagram for Boolean function, these Boolean functions. So example, you want to implement this function f with the which is x prime y plus xy prime. Okay, you want to implement this with actually electronic gates. Okay, with the sorry digital gates. So you already know whatever you see here, you take a look to this function that you have. Exactly, you could recognize the all operator that you have inside this function. You tell me, what do you see, which operator you see inside this function f? Just tell me the one of them. Which of these 8 operator that we learned in the beginning of this class, you could see them inside this function? Yeah, definitely you see and. Where is the and? And is here. X prime and y. You see or. Where is the or? Or is here. Okay. So that means if I want to implement this, you say, okay, I see one or. How I could implement or? Definitely with the or gate. You put one or gate here. Okay. So then you say, okay, I see 2 and. Where is that 2 and? So this is the first and, which is implement what? Implement x prime dot y, but you just have x. Definitely you need another not, which is produce x prime, right? So then it's actually is one of the inputs. So the next input is actually y, right? So what other terms you have? X dot y prime. So the next should be another and, right? So you need these y prime, so which is you take a not of that. So then you need actually the x. So maybe that's better to do this, actually have this as a x and give one to here. Okay, so then you actually let to write with the other color what you produce in each line. Here is x, you passed from the not, you actually made x prime. So here you just have y. Here is y, you have y prime. Okay. So what should be the output of this? This is and x prime y should be these output. What should be these output? Should be x y prime. Okay. And what should have here? You should have the f, which is x prime y plus x y prime, which is equal to f, right? So if I back here and complete the circuit, so definitely should be goes to the 1, and this should be goes to the here, and the output should be f, right? So this is what's the meaning of implementation of the Boolean function with gates. If I give you any any function, okay, any function, you should able to implement that. You just take a look where you use and, where you use or, just implement that with this gate. So I forgot one thing, which is that's better I mention to that for XOR and XNOR, right? So I talk about the XOR, which is this one that you see here. So the definition of the XOR is this: the XOR of X and Y is X Y prime plus X prime Y. Okay, so this is actually the definition of these XOR, which is the follow the same actually truth table. You could actually test that, give the different value you should give. You could see this function is exactly this table that you see. Okay. Similar with this, for the XNOR, you have the same thing. You have actually the definition of this table that we already mentioned. You could say it is xy plus x prime y prime. This is actually the Boolean function which is produce these truth table that you have. Okay, just I forgot to mention to that. Okay, so this is how you could implement the Boolean function with the gates. So it has actually one other side, which is you could, if I give you any circuit, okay, with the gates, you should be able to tell me what's the related function or which function this circuit able to produce. Okay, so for example, if I give you this circuit, so again, this is the example that we have on page 55. Yeah, in page 55, question 2.4. Okay, so it's actually give you one circuit, which is to put one X here. It's take the NOT in the other side, and we have this. Then you have the Y, then takes a NOT and put here. So usually whenever you want to draw the digit circuits, this is actually one way you could actually get more clean drawing. Okay, so see, I want to connect these two to the AND gate. So I just do this. I put just AND here and one here, and just I put one line like this. So this has technically two input, but because I want to keep my drawing more clean, I just use one of them. But how I'm telling it actually is two by putting two dot. I put one dot here, which says one input is X, and another input is y prime. So that's what you put one dot here, okay? So whenever you see something like this, so that means the output of this AND is x, y prime, okay? So we are doing this because we don't want to have too many wire or too many connection and make one actually ugly drawing like this, okay? So this one, if you compare with this, is more clean. So that's in some books or some reference you see they use these kind of the things. So the next one, next and is connected to the x prime, which is you just put dot here, and actually it's connected to the y. Okay, so that means you have one dot here. So suppose you connect it to the or. Okay, so I give you this circuit and tell you what is right the yeah, that is a question. What the Boolean expression is implemented by the following logic diagram. Okay, so that means this is the opposite of this, right? I have the function. I say, okay, implement the function with the gates. This is opposite of that. You have the gates. It says, okay, write the function. This is actually produce, this circuit produce which Boolean function, okay? So for answer that, it is easy. You just actually comes to each gate and find their output. Here I did that. I say, okay, this is connected to X, this is Y, this is XY prime. So comes here. This is X prime, and with the y. Okay, then you actually use the or. So that means the f here should be x y prime plus x prime y. Okay, So this is actually the other form of that. In other words, we could say each circuits that you see in the digital system, we have a Boolean function for that. So if you have the function you could implement with the gates, the opposite of that is right. So if you just have the any circuit, which is the combination of the gates, you could actually find its corresponding function. That's what I did here. Okay. So we have some question in the homeworks, chapters 2 homework, which is asking the same thing. Give you a function and say implement with the gates. You need to do this, and or you actually get some circuit. It says, okay, what is the this circuit implement which function, which is with this explanation. You should able to get the corresponding function for any digital circuits.